Okay, hi guys. This is a video I've been wanting to make for a while. I've had this slideshow actually made up for a couple months, I think, at least before Christmas. Yeah, maybe end of November kind of area. Anyway, let's get into this video because this is a really, really good one that I've really been waiting and excited to present. So, climate science due diligence, right? That's what I'm all about. That was my whole approach to climate science in the first place was due diligence, which means going to first principles and figuring out where all this stuff comes from in the first place. So this is a basic application, in fact, of ontological mathematics to climate science. What's ontological mathematics means? It means just doing good physics, getting your math right for the situations you're doing, not using math that's wrong, basically. You got to use the math that actually corresponds to reality and how reality actually works, because if you're not using that math, then what are you using, right? What are you using? And we're going to tie into how this leads to a discovery of a war for Earth. Apparently, that's really happening. So I'm going to tie it all together. This is going to be a real fun one. I hope it was for me to make. Due diligence. What does due diligence mean? So we have this climate change thing that we, God's sakes, hear endlessly about. It is just the whole thing that we're constantly being bombarded with, right? Teaching it to our children. It's in the news every single day. So, people are debating about this. People are hating each other about it. People like me are getting fired from their jobs for freaking talking about it, right? You're not allowed to for questioning it, that is. You're not allowed to question it. But what do you do with due diligence? What should you do in science of all places when there is a pretty extraordinary claim that the planet is going to boil? They're literally using the term boiling now, that the oceans are going to boil, that the climate is boiling, that the climate is going to boil or something. That's a pretty extraordinary claim, given that the Earth has existed for 4.5 billion years. The climate's been relatively stable. There's never been any example of climate boiling. Carbon dioxide levels have been way higher. The temperature of the Earth has been way higher in the past. We're actually at a very cold period right now in Earth's geological history. This is a very cold period, and it's probably going to get colder because that's the history of the last few million years of being in an ice age. We're just in a brief warm period right now, given what the previous cycles look like and tell us, the previous history. And so the Earth was much hotter before, and it had, not in a correlated sense, but it did also have periods of much higher carbon dioxide. Those periods of high carbon dioxide aren't actually correlated with the warm periods, so there's no actual correlation. There's no actual historical geological evidence that increasing carbon dioxide will cause a planet to boil. Never happened in the past. Planet's been much hotter in the past for reasons that had nothing to do with carbon dioxide. So, due diligence. Let's see where this all starts. What does due diligence mean? It means you got to look at, where does the theory of anthropogenic climate change originate then? What is the origin in physics? Because I'm a scientist. Doesn't everything depend on science these days? Don't you need to know the reasons for things, right? It's not just a faith, is it? Shouldn't be. So what is the origin of the theory of anthropogenic climate change? What does it rest on? It actually rests in one place and on one thing. What are the foundations of the theory? What are the first principles in physics and math? What's a basic physics? It all rests upon this idea of a climate greenhouse effect. That's the fulcrum. That is the crux. That is what it all rests upon. The idea of a climate greenhouse effect. Yeah? Good. So where does this come from and how does it work? What is the origin of the theory of the climate greenhouse effect? Let's go there, because that's what you do in due diligence. Where does this all start? Origins of climate change. So I'm going to show you a diagram here in the next slide. But just to make it clear that the following diagrams represent introductory, pedagogy, and also peer-reviewed literature for understanding the basic features of the climate and the greenhouse effect of climate science, because the greenhouse effect of climate science is supposed to be one of the most basic features of the climate. So we're going to see ahead, where does that come from? Okay. Now, just to make it clear that this really is the basis of how we introduce students to understanding the climate, and therefore it establishes the basis for the filtering mechanism for how all peer review is conducted in climate science. As you know, if you've read my books, you've read about the results of that. What happens when you try to introduce a different alternative idea, which is really simple, and you see what the response is. That's of course in my book Planet Wars, where you can see that. So This is from, so just to demonstrate, but this is where it all starts from. This is Roy Spencer, a PhD in climatology. He's actually considered a skeptic, but he actually still defends the basis of the theory of alarmism, which comes from the greenhouse effect, right? So just to make it clear that this is a quote from him, and he says, what I'm about to show you, these diagrams, it is the starting point for all of climate science, and no one disputes it. Okay, no skeptic, and definitely not the alarmists and the people claiming this extraordinary claim of climate boiling. They certainly would not dispute it because that's what their whole theory rests upon, right? So, Roy Spencer, PhD in climatology, it's a starting point for all the climate science. No credentialed skeptic, no one else would ever dispute this. Okay, so where does it start? How do you derive the greenhouse effect of climate science? You derive it from these diagrams. This is just an example. I remember in my second year of astrophysics training at the University of Western Ontario, my second year undergraduate honors program in astrophysics, I learned a diagram like this in a course called Planetary Science, how to explain the temperature of the Earth. And I was taught a diagram just like this. And it's interesting that you can get taught things like this when you're in school and you don't criticize what to me now is so obvious to criticize. But when you're a student and you trust your professor is telling you something, well, you just sort of go along with and trust it. Okay, so Harvard, University of Chicago, Harvard University, Columbia University, Penn State University, University of Washington, and then this is a peer-reviewed reference here, American Meteorological Society. Okay, so they're all showing the same sort of idea. You have a surface and an atmosphere, and then a bunch of arrows and sort of math equations which demonstrate the physics of what's going to happen in that scenario, of what's going to happen, right? This diagram is the same thing. This diagram is using the numbers. It's a little bit more involved because this is an actual peer-reviewed literature rather than just coming from a teaching university classroom material. So there's a bit more detail in this one down on the bottom right. But the numbers you see here come exactly from this process. What's demonstrated here, what they're doing here has just been made into a little bit more complicated scientific looking thing that goes through peer review and is in a published journal. Yeah, okay, so here's my question at the bottom. These diagrams demonstrate the universal starting point by which climate science then derives its greenhouse effect. So yeah, that's what they're doing in here. What they're doing in these diagrams is deriving the greenhouse effect, showing how the greenhouse effect works. I'm not going to get into the technical details. I've done that in my books and I've done it in other videos, and if I start doing that now, it'll get boring. Anyway, what they're doing is they're showing how to derive what they say is the climate greenhouse effect, right? That's what they're doing in these diagrams. Okay, but I say, look past the math and see what the math is being developed for. What is the math being developed for? Okay, so when you're taught this, you're taught that this math is being developed for how the climate works. Okay, now let's put that aside and just say, if we're just shown this without that context, what would we say that the math is being developed for? We would say that like geometrically, you would say, oh, the math is being developed for a flat plane, right? For a flat line, because that represents a flat plane. That's what you would say, right? Okay, well, initial premises. This is from Mike Hockney. Actually, this is paraphrased. I'm not sure he said it exactly this way, and I'm sure many other people have said this in the past. Certainly, it's not a new idea. But if your initial premises are invalid, then everything which follows from those premises is likewise corrupted. So if you have an initial set of axioms, initial set of premises, but there's something wrong with them, well, if you just extrapolate conclusions from them, your conclusion's just not going to be right. It's going to have the same error as the origin, right? The originating error, you have an error at the start, it's just going to, and you keep that error in the whole way, and you never resolve it, where you're going to get to some wrong conclusion, right? A pretty simple concept, isn't it? In logic and thinking. So is it relevant, or could it be a potential problem that climate science starts with flat lines for the Earth? Are those premises, is that a good set of premises? I mean, could it be a problem? I mean, I'm just asking because you know what the Earth actually is, right? You know that the Earth is a sphere, right? So could it be a problem in physics and math and logic and philosophy of how this all works out, that they're deriving something based on flat lines being the Earth, a flat line being the Earth, which would imply a flat Earth? I mean, is that a potential problem? It's a potential error in the initial axioms? Yeah, I mean, maybe, right? So is it ontologically valid mathematics for the whole Earth? I mean, as an empirical scientist, you're going to say, well, go check the measurements and forget about theory. As a philosopher, I would say, well, I think it's pretty safe to say that a flat line mathematically for the Earth, for the whole Earth, yeah, that's not ontologically valid. A sphere would be more ontologically valid, or like a circle drawn as representative of a sphere on a 2D plane, how we can draw things. That would probably be more ontologically valid, right? I think philosophically, logically, you should be able to say that. But if you want to be a pure empiricist and say, go check the measurements, we can do that too, actually. So does it correspond to ontologically, empirically possible reality? That's a good one. Is it ontologically, empirically possible, right? So in fact, it's not ontologically, empirically possible actually to have a planet that's a flat line, right? Because of gravity and other things, we know that anything big enough to be a planet is going to pull itself into a sphere because of gravity, right? It'll rearrange itself. Even if you started off with a flat plane for a planet, it's going to squish itself and crunch itself into a sphere because of gravity, right? So it's not actually ontologically, empirically possible at all in reality, at all, to have a flat plane planet, right? That's not mathematically possible. It's not physically possible. It's not empirically possible, not theoretically possible, right? So that's kind of a good philosophical argument. Again, if you want to discount the philosophical logical argument and go to pure empiricism to measure whether it makes a difference, we can do that too. So here's the proposal. Let's use a sphere for the Earth instead and see if it makes a difference. So why not try? Why not try a circle as representative of a sphere on a 2D plane that you're going to draw a diagram of and see if it makes a difference? And here's a question. Can it even be done? Can it even be done? You'd almost think there's a lot of people out there. I mean, if you've been following me, we'll get into it in a few slides here. There's a lot of people that would make you think that it's not actually possible to depict the Earth with a circle as representative of a sphere. That's they would say that's a wrong thing to do at all. It's much better to go with a flat line. Anyway, let's get to that. So here's a sphere energy budget. Here's the Earth drawn as a sphere, and then instead of having this sort of scheme where they're inventing this greenhouse effect, blah blah blah, you just have a sort of different set of physics working out, right? So yeah, you can draw the Earth, which is a sphere, represented as a circle instead on your 2D diagram. Yeah, that is possible. It is something you can actually do, right? And and then you have your energy from the sun coming in, and you have a daytime that's lit, and you have a night side, which is the shadow of the Earth upon itself, right? Then you have some, here's some related equations. I'll get into this in a bit. If you've been seeing my recent live stream and a few follow-up videos about the adiabatic effect, you'll kind of recognize what this is all about here. But you can do this, and you can so you have the input energy from the sun, you have the output energy from the Earth, and the Earth's output temperature. And so, yeah, it can be done. So it can actually be done. Great. Now, comparison. It is possible, so it is possible to use a spherical Earth for a pedagogical energy budget for use in understanding the basic features of the climate. That is a possible thing to do. You can do it. It can be done, right? So does it make a difference, though? Does it make a difference? Is ontological mathematics relevant to understanding physics in our world or not? If there is no difference, and in fact, some people even claim that the flat line approach is better. I'll get into that in a few slides. But the point here is there a difference between the math of representing the Earth as a flat plane versus the math of representing the Earth as a sphere? Is there a difference? I mean, if there's no difference, if there's no scientific difference, then why is it a concern? Then why did Eratosthenes try measure the circumference of the Earth 2,500 years ago? Why was that an important thing to do, right? Why do we make fun of people who are, the flat Earth trolls online, right? Why is flat Earth rejected generally in science, except here in these diagrams in climate science? It's accepted there, but generally in astrophysics and astronomy, we generally reject the idea that the Earth is flat. I mean, so does it make a difference, or does it? It seems to be an important difference, actually, right? So is there such a thing as correct mathematics corresponding to reality, or is any math always correct for physics? Well, no, I think all people know that. There's a correct physics. There's a correct math for the physics of how reality actually works. And there can be math that doesn't actually correspond. That's wrong math. That doesn't correspond to how reality works, right? Or that's not relevant to physics, right? Yeah, I think people generally recognize that no, not any math. It has to be the correct math, right? Right? So flat earth math can't really work out, can it, ultimately, to represent the earth? I've discussed this elsewhere. Could you do orbital mechanics? Could you launch a rocket and a satellite into space using flat earth math? You can't. You can't do it. It's impossible. It would be impossible. If we had thought that the earth was flat, it would have been impossible for us to ever develop the theories of Newton's laws and the equations necessary to put a rocket into space, a satellite into orbit around Earth. It simply would have never occurred to us, never been possible with flat Earth math. With round Earth math, that is a possibility. So isn't that a pretty important difference, right? That's important. Physics and logic and philosophy all tied together, isn't it? Gosh, scientists don't care about having these discussions anymore, as we're going to see. So here's the difference. So I have my, circle as the Earth here, which is, representative of a sphere. This is a slightly older diagram than the one we just saw back here. This one's been updated and made a bit bolder and bigger to make it a bit more clear, but basically it's the same diagram anyway. So what are the differences? So here's on the bottom, you have the standard approach, which Roy Spencer says is the universally accepted starting point for understanding climate science in the field of climate science, climatology, right? And then here's what I'm suggesting: use a sphere instead. So does it make any difference? Yeah. So for the math with the Earth being a sphere, you get, for example, that the solar heating is 121 degrees Celsius. That's how hot the sun is. For example, at the moon, which is basically the same distance from the sun as the Earth is, right? So on the surface of the moon, temperature sensors up there on the moon actually get to 121 degrees Celsius, because that's how much heating strength, power the sun actually has. Astronauts and satellites in space in orbit around the Earth also experience that. That's measured, right? So that's pretty hot. On this flat Earth approach, they look what's happening here. You see that? The flux of the sun, that basically means the power of the sun. And then they divide it by 4, right? So they take the power of the sun divided by 4. That's what you have to do as a consequence of flat Earth math. On spherical Earth math, you just use the power of the sun straight up. That's just straight up coming on the Earth, right? That full power of the sun is falling on the Earth. Well, on a sphere Earth, right? For flat Earth, they first have to divide the power of the sun by 4 and then put it on the Earth where the Earth is a flat plane. Wow, guys, right? There's a difference in how the math is working out. That's a difference in how the physics is working out, right? So when you do that divide by 4 thing, you get that solar heating is only minus 18 degrees Celsius. Well, gee, that's freezing cold. How the hell can we have a climate if the solar heating is only minus 18 degrees Celsius? How can the how can the sun create a climate? How can the sun create a climate if the sun is only heating Earth at minus 18 degrees Celsius, full strength, right? That's a pretty big difference in physics we're getting to now, right? Because with the spherical approach, you get that the solar heating directly on the Earth is 121 degrees Celsius. Well, geez, that's hot as hell. That's hotter than the boiling point of water. That's certainly hot enough to create the climate, to create wind and convection and to melt ice and things, isn't it? You get real, actual climatological responses. Ice melting, pools of water evaporating. All that can be explained by the direct heating of the sun on a sphere Earth. Oh, wait, but you can't explain those things on a flat Earth where the math requires that you use 1/4 solar power. You can't explain ice melting. You can't explain pools evaporating and becoming clouds. You can't explain that coming from the sun, right? And that's actually what their greenhouse effect is invented for, to do instead. So what do you think? So here we've reached the conclusion now. So what do you think? Should we use a greenhouse effect to explain why ice melts and why evaporation happens? Because the sun has been written out, basically, of the climate because they're using flat Earth theory? Or is it a better theory to use the actual power of the sun as it's actually coming in and recognize that it's the power of the sun, which you can just go outside and feel, and measurement, right? And it's the power of the sun which creates the climate. Yeah, and as far as empirical proof, okay, so some people might say, well, there's only a theoretical difference. It's not that important. Okay, well, fine. Let's be an empirical scientist then and go measure. As I said, if you go measure by placing something on the moon, by placing a satellite in orbit, this is the actual power of the sun that you measure. You do measure 121 degrees Celsius worth of heating power from 1,370 watts per meter squared, approximately, That is what you empirically measure from the sun when you're in space. It is, right? You do not measure the power of the sun divided by 4. If you were to measure, and you can work this out theoretically, where would you find the power of the sun divided by 4? You would actually find that at a location twice the distance that the Earth is from the sun. That's where you would find it, right? So now we're getting into inconsistencies. So the flat Earth approach requires that the sun must actually be twice as far away from the Earth as it actually is. Whereas with the spherical approach, you just use the sun where it actually is, one astronomical unit, which means one standard distance between the Earth and the sun, right? So sun creates climate. So another difference is, heat flows from hot to cold. That gets into thermodynamics. That gets really technical, mathematical, etc. But property of heat, basic property of heat, is that heat flows from hot to cold only. Their greenhouse effect scheme, in order to get the climate to create itself, since the sun isn't creating climate, they require heat flow from cold to hot. Of course, they'll deny that that's what's happening, and they'll use other terms like, no, it's not heat flow from cold to hot, it's trapping heat. Well, saying trapping heat is just as stupid and just as bad as saying that heat flows from cold to hot, because heat cannot be trapped. Heat is not a substance which can be trapped. So that's just a nonsensical term. So you start really generating a whole bunch of paradoxes and conflicts with existing physics and empirical knowledge when you use this flat Earth approach, right? So yeah, it's a static flat Earth, right? It's static. There's no day and night. It's just a plane facing the sun. There's no, how can you have day and night on that? I mean, God, talk about a basic feature of Earth's climate: daytime, nighttime. Pretty basic feature. You can depict that on a circle model, which represents a sphere, a day and night side. Of course you can represent that. Here, the top hemisphere is the daylight that's being lit up by the sun, and the bottom hemisphere is the Earth shadow upon itself, right? The night side. Yeah, no problem. Here's a big one. The flat Earth approach claims that this greenhouse effect scheme of back radiation, what they call back radiation, is responsible for creating what is called the temperature lapse rate in the atmosphere. So the temperature lapse rate is where the bottom of the atmosphere is the warmest part of the atmosphere, and then it cools down almost linearly, sequentially, to the top of the troposphere, where the top of the troposphere is coldest. So that's temperature lapse, meaning change in temperature with distance is what that means. Temperature lapse means change in temperature with distance, and that changes that it's decreasing in temperature. The bottom of the atmosphere is the warmest part. Its averages in the middle, and then the coolest part of the atmosphere, the troposphere, is coolest at the top, right? So hottest at the bottom, coolest at the top, and it basically a sequential distribution, right? Linear distribution. So they claim, the flat Earth method claims that the greenhouse effect and back radiation is responsible for that. However, when you go to the spherical Earth and you apply standard physics, which is called the adiabatic effect, you find that the adiabatic effect, and that's due to the power of gravity. You have rising air cells, a rising air and falling air due to convection, due to heating from the sun, because the sun actually does that, right? So the sun drives that process. In their minus 18C heating model of the flat Earth, the sun can't drive that convection, right? So, but on the spherical Earth model with real high intensity solar heating, the sun can drive that convection, can drive those molecules to ascend and descend, and generate convection. And actually, this adiabatic effect, it actually doesn't even require a bulk convection. It actually happens on a molecular level anyway. At the atomic scale is actually where it develops anyway, because some molecules are bouncing upwards and some molecules are bouncing downwards randomly, and it's basically like this: if a molecule bumps up, gravity travels upwards, gravity slows it down. Just like you throw a baseball up in the air, and what happens? Gravity slows it down, right? Whereas if it's falling down, if you threw a baseball downwards, it's going to speed up even more because gravity is pulling it down faster. And so that actually originates at the atomic level and creates this distribution in temperature, because there's basically more pressure and more faster movement on the molecules as they descend compared to the ones that ascend, and that's what creates the temperature distribution. Anyway, it's called adiabatic physics. This is the equation for it. You can factor in then, as I showed in my live stream and in the adiabatic lapse rate video recently, that you factor in latent heat from water vapor together with, it's basically, all it is the strength of gravity. That's what G is, over the thermal capacity of air, which is the CP term. So it's just the strength of gravity divided by the thermal capacity of the air. That's it. And then you have to add in the latent heat capacity of water vapor, because as the air column rises, the latent heat from the water vapor comes out. Anyway, you do that and you calculate perfectly the lapse rate. You perfectly get it. So it actually shows that you get the lapse rate, the temperature distribution, that the bottom of the atmosphere is hottest, the top is the coolest. You get that straight out of adiabatic physics. So that is the physical mechanism. This is well known, and it's a physical mechanism, and it's caused by gravity, and it's empirically confirmed, and the theoretical result matches up with the empirically measured result. And so boom, there you go. You explain why there's a lapse rate. Whereas they're claiming that it's this greenhouse effect physics on flat Earth which creates the lapse rate. Okay, well, which one is true? One is depending on the Earth being flat. The other one is depending on nothing else but the Earth being a sphere, and the fact that adiabatic physics work, in gravity and heat are real things, and that thermodynamics just work. This is all well accepted. Everyone knows that this is what it does, but for some reason there's a split in people's minds, among the climate science community when it comes to the greenhouse effect. They don't realize that these two things contradict each other. They both can't be true. Either one or the other is creating the temperature lapse rate in the troposphere. All right, getting too long on that. All right, so one last thing, Earth's effective temperature, that means the temperature of the Earth is the output of the Earth only, right? So that's your minus 18 degrees Celsius, right? Oh, that's interesting, right? Because I've been talking about minus 18 degrees Celsius from the flat Earth thing. And that's what their input is, right? They actually use an input of, see, it's the same equation, right? That's the F from the sun divided by 4 comes out to minus 18 degrees Celsius. That's what they have here, but they have that as the input. So I have on a spherical Earth minus 18C only being the output and the solar input being the solar input. For some reason, as a consequence, actually, in fact, of the flat Earth math, they have the Earth's output being used instead, which is minus 18 degrees, being used as the solar input too. Because it's flat Earth, you have to equate those two things. So that's interesting, right? So which is it? Is the solar input just the solar input and it's really hot? Or is the solar input divided by 4 and it's really cold, right? So, I mean, come on. This shouldn't be rocket science. But this has been called, my spherical Earth idea model, and tying it together with just the fact of the lapse rate, which everyone knows, except what they refuse. They just sort of put blinders on that and put it aside when it comes to the greenhouse effect. It's been called crank science, and but this stuff, the flat Earth stuff, that's pedagogical, means it's taught at introductory levels, and it's peer-reviewed climate science. Great, so let's look at the incredible gaslighting, which happens as a result of showing people this diagram, this comparison. What do I get from that? So this is from Eric Donovan, which is a professor at my old university, University of Calgary. I tried discussing this with him. And he says, Joe, you are dangerous and ill-informed. Words cannot express the level of my disrespect for your criticism of climate science with flat Earth. So, I mean, help me understand that, and I was kind of trying to maintain an email communication with this fellow, but after he sends me this, I don't know what I'm supposed to say to him. Like, I really don't know how I'm supposed to follow up with Eric after he says something like this. I'm like, Eric, I'm just saying that you can depict the Earth as a sphere with a circle and that it makes a mathematical difference. Don't you think it's important to acknowledge that difference scientifically between how the math of flat Earth theory works out versus the math of spherical Earth theory? Don't you think there's a difference between 121 degrees Celsius input from the sun versus minus 18C input from the sun? I mean, these are basic science questions. I kind of don't know what the hell to say to him anymore. Not that I really want to talk to him anymore, but some days I do. Sometimes I'm like, God, I'd really like to resume communication with him. But then I read the last email, which is this from him, and I'm just like, I don't know how the hell to freaking develop this conversation and maintain this conversation anymore. Okay, this is from someone on Facebook. This is a guy who's a very, very well-educated climate person, apparently. He seems to be a professor at some religious university or college or something. And if you look at his posts on Facebook, he's quite knowledgeable about how the climate alarm, or, the anthropogenic climate change theory and all that is supposed to work out. So look what he says after I presented this. He says, Joe's theory, my theory that the Earth is a sphere, and that you can do physics and math with a sphere. For some reason, this guy says Joe's theory fits every definition of a crank theory. It's obviously absurd, violates known laws of physics, and is propped up by postman's ego rather than evidence. Okay, so it's my ego saying that you can depict the Earth as a sphere by using a circle, and probably that's a better way than depicting the Earth as a flat line, which implies a flat plane. So that's me being egotistical, and it's also has no evidence that this would be a rational thing to think, and it's crank theory. I'm now just some crank crackpot, right? That's great. That's where my career ends. I'm a crank crackpot because I said that you can depict the Earth as a sphere instead of as a flat plane for pedagogical climate science, and because that ends up in a different conclusion than the climate alarmist anti-carbon dioxide narrative. Yeah, well, now you're a crank and you're not allowed to work in science anymore. Violates no. I'd like to know what physics I'm violating. It's just a sphere. It's just the empirically measured strength of the sun. Doesn't saying that the Earth is flat and that the solar strength on the Earth is only minus 18 degrees Celsius. I mean, isn't that violating known laws of physics and has no evidence? Okay, I mean, we're going to get into the meaning of such comments. Now, this one's a real good. This one's real clever. Look at this. So Jordan Holmes, again, seems to be a very well-educated fellow. I looked on his profile, looked at his other comments that he's been making on Facebook on the climate pages, and very educated fellow, seems very scientifically informed, very scientifically well-educated. Now, these are not trolling comments. These are very trolling comments. So look what this fellow says to me. He says, a flat line can definitely represent a sphere. What are you talking about? And then he goes on. So I mean, just there, it's like, you know, a flat line actually can't represent a sphere. I mean, it's just like, here's a flat line. It goes out like this for infinity. Here's a sphere drawn, and you have to draw that as a circle. I mean, those aren't the same thing. And the flat line really can't represent the sphere. The only condition under which a flat line could represent a sphere is if the sphere were infinitely large. That's not what we're talking about. That's not the realm of physics or math we're talking about. We're talking about finite objects. Okay, I mean, just God. Meanwhile, he says, you are the one. Now, just read this. This hurts my brain. Meanwhile, you are the one treating the Earth as if it is fully illuminated everywhere at once, which is only possible if it were flat. You are the flat earther and ranting about how everyone else is. So this was after I had posted this and just explained that I think it's better to draw the Earth as a circle, which therefore represents a sphere, because it has math which works out differently and it's more empirically consistent because you get hot sunshine. I think that's probably a better way than drawing a flat line for the Earth. And then he says, meanwhile, you know, and of course, when you do that, when you do it with a circle sphere, you get a day side and a night side. That's right there. Like it says right there. I think on the new one. Okay, well, whatever. It's obvious, right? That's lit. That's dark. So that's day side. That's night side, obviously. Whereas if you have a flat plane, well, there's no variation in illumination indicated. Obviously, it has to be uniformly illuminated. But he says, no, you're the one treating the Earth as if it's fully illuminated or everywhere at once, which is only possible if it were flat. You are the flat earther and ranting how everyone else is. And that's right after I had said, I don't think it's good to draw the Earth as a flat plane. So, and these aren't trolling. Like you would think, well, come on, Joe. He's just trolling you. He's just trolling you, Joe. You idiot. Like, don't you recognize you're being trolled? Stop taking it seriously. No, these are serious comments. And I've dealt with comments like this for 15 years almost. Comments just like this for 15 years. All across the world, from scientists all over the place, of course. In my book, Planet Wars, you guys know how what I sussed out about that and what my conclusions are about that. I think I have that ahead here. Anyway, it's in my book, Planet Wars. All right, so a friend of mine says, these people are completely batshit crazy and they can't recognize it. Yeah, they have parasitically infested minds or something, or they are parasites themselves, right? Because it's kind of not possible, right? So let's look at, that was supposed to be in the background. Yeah, I was going to put that, but it's too much text. So anyway, so then I put it here. I tried to simplify it even more. So I said elementary geometry for climate science. So on the left here, this is a circle. It represents a sphere. Yeah. This is a line, it represents a plane because that's the only way that you can draw it. If you're going to draw a plane edge on, you have to draw it as a line. If you're going to draw a sphere on paper, you use a circle, right? These are geometrically, qualitatively, and quantitatively different, right? They're different things. They don't transform into each other. So this is a sphere being illuminated by a distant point source. Okay, yeah, perfect. That same sphere, now there's a light on here, so you get the day side on the top, and the bottom then is in the dark, right? This, however, on the right would be a plane being illuminated by a distant point source. Well, that plane needs to be illuminated everywhere once because the point source is different, so it's going to get uniformly illuminated over the whole thing, right? And now it's the same thing, and I'm just adding the solar constant, just adding the strength of the sun. Oh, usually I use 1370 here is the slightly more empirically confirmed value of 1368. Basically, I mean, just within air. So 1368, 1370 watts per meter squared. That's the strength of the sun. That's a numerical value of the strength of the sun, right? Whereas here is the numerical value of the strength of the sun, that value divided by 4, which is what they do in flat earth climate science. In pedagogical peer-reviewed foundational climate science, as Roy Spencer says and tells us, is foundational climate science, dividing the strength of the sun by 4. So you get 342, right? So, question. Which column represents the sun shining on the earth, and which column represents flat earth theory? Can you answer that? Is it really a difficult question? Question 2, are both columns equivalently scientifically legitimate for representing the sun shining on the whole earth? Can you answer that? What kind of person are you inside? Can you answer it? Question 3, if one column implies that the sun can create and sustain Earth's climate, while the other one rejects that, says that the sun cannot create or sustain Earth's climate, would this represent a difference in how to understand the climate? Pretty basic question, right? Now look at this response I got. Below this, I posted this somewhere on Facebook. So look at this response from Willis Eschenbach. Willis Eschenbach is the guy who came up with that steel greenhouse idea, which is what I used in my first book to show that it results in a solution of 1 equaling 2, which means that the whole scheme that they come up with for how this back radiation greenhouse effect has to be impossible because it results in a solution where 1 has to equal 2. And then I showed how to do it the right way with correct thermodynamics, and then that thing is fixed, and then it shows that there can't be a greenhouse effect, which is of course consistent with the greenhouse effect coming from flat earth theory, which means that it can't be true on those grounds as well, right? So he's the guy that came up with it. And, and I demonstrated that to this guy, and I talked to him about that back in the day. And you know what his response back then was to my pointing out that his solution results in 1 equals 2? Do you want to know what this guy, and this guy is very well respected in this so-called climate science community. How is that possible? How is it possible that this guy has tons of clout and has carried on some of the biggest climate skeptic, climate science sites out there when he does stuff like that? So yeah, what did he say? What did he say about 1 equaling 2? He said it's a negligible difference. He said, and I showed him how it results in a violation of the law of conservation of energy. And he said that when you have 1 trillion joules, then a difference of 1 billion is negligible. That was his argument. So in regards to how he can get around the law of conservation of energy, how his model of how the greenhouse effect would have to work can get around the law of conservation of energy. He says because the difference is negligible. Of course, he can show that it results in such a big difference that it's 1 equaling 2, which is 100% error, right? But he says if you go to the scale of the Earth, then it's, comparing 1 billion to 1 trillion. And so that's a negligible error. It's like, okay, fine. So that means that the law of thermodynamics isn't that energy can either be created or destroyed. It's that energy can be neither created nor destroyed except for a tiny little bit. So is that actually how the first law of thermodynamics is defined? It's not defined that way. It's defined that energy equals energy, that energy can neither be created nor destroyed. It is not that energy can be neither created nor destroyed except for a tiny little bit. But that's what he wants you to believe. So anyway, going on, he saw this. I didn't address this to him. He just, I guess, either I'm friends with him or he's, you're friends with everybody on Facebook, people you don't even know or like, right? Happens. He responded to this and he says, Joe, I have no clue what complicated, dense, impenetrable word salad that might mean. Please boil it down to a too long didn't read if you'd be so kind. It's like, Willis, like you write about thermodynamics and physics and climate science and how you think that the greenhouse effect should work and the flat earth theory is okay, and you have all these very scientific sounding arguments. You're telling me that you can't answer these frickin' questions? But of course they can't. Of course he can't answer those questions. If he did, it would frickin' destroy his whole shtick and everything that he's been defending, right? As a pretend skeptic. He's supposed to be a skeptic. He's actually defending the basis of climate science and climate alarmism, right? That's actually what he's doing. They're fifth column operatives, right? He's got a parasite infected in his mind, or he is the parasite, or he's being controlled from some other means, or he's just, a sellout or whatever he is, right? Because what a freaking ridiculous response. You have no clue what this question means. You can't even comprehend the question being asked here. Please boil it. This is the TLDR, Willis. God's sakes. Anyway, that's what you deal with. So, paradox. In science fiction, for example, you'll recognize this was a common plot line in Star Trek The Next Generation. It also comes from like Sherlock Holmes, those type of stories. Paradox is one of the most common stories, genres of story generation, how to generate a story, generate a mystery, right? It's basically just generating a mystery so that you then have to solve it. Well, why? Because a paradox is impossible and the impossible cannot exist. So what does it mean? It means that there's something that you don't understand, right? It means that you have to go to a new higher level of thinking to solve this paradox, because this paradox is impossible. Therefore, if it exists, there's actually a reason for it, which makes it possible, right? That's classic Sherlock Holmes. A lot of science fiction is based on that idea, right? So therefore, the existence of a paradox of the impossible indicates a purpose or a valid rational mechanism which created it. It only seems impossible, right? This necessitates a pursuit to comprehend its nature outside the box. That requires expanding your thinking, expanding your knowledge, right? And that's why science fiction people love that, because it's all about, expanding your knowledge to vistas unimagined before, right? That's what science fiction is all about, right? This is like a rift in the space. So why does this rift in the space-time continuum exist, for example, right? And what to do about it. Classic line from Star Trek TNG, right? Rift in the space-time continuum. So has anyone else ever encountered a rift in the space-time continuum? Has it happened to you? It happened to me. It happened to me because these showcased comments from the previous slide are a rift in the space-time continuum. They're impossible. These comments are impossible, right? When Willis says that to this, that's impossible. When these people who are professors and highly educated science people say these things to me, that's not possible. It's a rift in the space-time continuum. It's a paradox, especially Jordan Holmes. I mean, talk about a paradox. And like I said, he's not trolling. He's dead serious, and he will repeat this at length, and you can explain it to him and explain that, no, I'm actually for spherical Earth. I'm showing that I don't like flat Earth. And it's not trolling. He's quite serious, and he will go on and explain it to others and explain why it's not trolling. It's not just a one-off troll comment. They will spend months and months repeating these things and saying these things quite seriously, right? So these are impossible things to find people, especially scientists, saying. They're a rift in the space-time continuum, right? They are a rift in the space-time continuum. They're not possible. That means that they're purposeful and that there's a reason behind them, which you need to go to a higher level of consciousness and awareness of how reality works around you to understand. That is in my book, Planet Wars. That summary and what was solved about that problem in my book, Planet Wars. Okay? Has an explanation, has a purpose, has a reason. The problem is figuring out what it is, right? So it's simple. It's not that difficult, actually. The purpose is the endpoint. The purpose is the endpoint of their goals. That's the purpose. That's why it exists. Of course, the question, well, who would have that interest? So that's what's in my book, Planet Wars, explaining who exactly, what type of people would have such an interest as this endpoint we're going to discuss here. So there are movements arrayed which wish to commit to mass-scale geoengineering and what's called solar radiation management, which means blocking out the sun, with either particulates in the atmosphere or with an actual solar umbrella that's built in space between the Earth and the sun to block the sun out from the Earth. It's kind of like that episode of The Simpsons where Burns says, since the beginning of time, man has yearned to destroy the sun, except it's not a joke anymore. These people actually want to do it by blocking it out. And that's actually what Burns does. He creates a solar umbrella that goes above the city and blocks out the sun. And these people are talking about building that in space. Like, what the fuck? Right, guys. So, due to climate change, we must engage in global geoengineering and solar radiation management and CO2 removal. That's what we must do, which is also anthropogenic climate change, because, right? So, they're saying we need to do anthropogenic climate change in the form of geoengineering. So, this is climate change to stop climate change, right? So really, they're actually saying they want to do massive climate change geoengineering projects in order to stop climate change, right? Kind of paradoxical, interesting, right? So what happens? What happens if we give them what they're asking for? So what are these people? We know what they're asking for. They've said it in my live stream that I did about what was that one called? Planetary physics a few months back. I've quotes saying that they want to be able to work extra governmentally. They do not want to have to go through governments. They do not want to have to go through the voting process and be voted for approval. They want to be a separate entity group working, obviously with governments only in the sense that governments pay them. They want the money that governments can collect from taxpayers. That's what they want. But they don't want to have to be limited by governments limiting through whatever the populaces vote for. If the populace says, no, we don't want to pay for these things, they don't want to have to face that. So basically they want, independent, complete control with the governments giving them unlimited funding with governments unable to stop them. That's what they've asked for. They've asked for, like, the numbers are ridiculous, like trillions of dollars. I think $50 trillion is even one number that's estimated. And they're saying, yeah, that's definitely what we need to do. Yeah, we definitely need $50 trillion from taxpayers over the next 50 years. And we're going to build a solar sail between Earth and Sun. And we're going to genetically engineer some new life form bacteria, which will exponentially replicate and suck all the CO2 out of the air. And we also need to build some giant factories, these giant vacuums that'd be like, like basically the size of small cities, just the big machines that chemically suck the air, like giant vacuums that basically suck the carbon dioxide out of the air and take it out. And that's what we're going to do. Okay, so you give us, we don't want to have to be voted in. We don't want this to be approved by voters or by government. We need to work extrajudicially, extra governmentally, and we want all the funding to do this. Okay, so let's go ahead and let them do that, right? Remove with carbon dioxide and block sunlight. Well, come on, so you know what the risk of that is, right? We're talking about geoengineering on the scale of evolutionary geological impact, right? We're talking about geoengineering on the scale of energetic impact, which of billions of years, basically geological, evolutionary, energetic impact, which occurs at the scale of billions of years of development, because we're talking about photosynthesis, the basis of photosynthesis. You block out the sun and you remove the CO2, what happens? You stop photosynthesis, you end life, you completely radically change this environment to something that's not suitable to photosynthetic life anymore. And it's well known. Everyone knows that life and plants love more CO2. We put more CO2 in the greenhouses because the plants love it, makes them grow more. The planet has in fact been greening because of the increase in carbon dioxide, which again, I'll just, as a caveat, point out that it's probably not actually humans that are causing the increase in carbon dioxide. It's coming out of the earth itself. The earth is just outgassing it from the mantle and volcanoes. We have the little curve, it's called the Keeling curve, that's measuring the increase of CO2 over the last, whatever it's from. I think it started in the 70s or 80s or something. But that curve is just a nice smooth increasing curve. And when you have global lockdowns like the pandemic, where there's a massive reduction in driving and hydrocarbon use, and when you had the oil crisis, when was that, about 15 years ago, and a massive slowdown because the oil price just went through the roof, massive slowdown in economic activity, which should correspond then to, if it's all from humans causing this rise in CO2, then it should cause a little blip in that rising curve. That rising curve should blip down when there's an economic downturn, right? Because the numbers are there. We know that there's massive downturns in how much hydrocarbons and fuel we're using, right? No blip, that curve just keeps going straight up. So, or not straight up, it just keeps on increasing a little bit, right? So yeah, so it's not even coming from humans, the CO2 in the first place, right? And everyone knows that. Everyone knows that result. Everyone knows that plants love more CO2 and that it helps plants grow. Everyone knows that geologically, evolutionarily, CO2 has almost always been much higher than it is today. Everyone knows that if CO2 actually goes too far down, the danger is you stop photosynthesis. You don't need to go down to 0 CO2 to stop photosynthesis. You actually only need to go to a little bit below where it was before it started increasing. And it started increasing before humans were significantly using hydrocarbon fuels. All this is known, but they just freaking ignore it all, right? So the Earth itself started out gassing the CO2 well before humans were using so-called fossil fuels or hydrocarbon fuels to any significant extent. So the Earth started doing that. Maybe it's a mind of Gaia thing or just random geological, whatever it is. The Earth was already and seems to be what the source of CO2 is. It's just coming out of the mantle, out of volcanism. Okay, so given that even though that's all known, they want to work on this project for the next 50, 100 years to block out the sun and come up with schemes to just suck all the carbon dioxide out of the air. That's mass scale geoengineering. That would transform this planet into something not suitable for photosynthetic life. That's what they want to do. That's their endpoint. Because how do you explain the paradox of their ridiculous freaking comments? How do you explain that paradox? That is such a freaking paradox. These comments are so freaking paradoxical to reality. They're so paradoxical to what you would expect a normal human would be able to produce, right? They're simply not what a normal human should be able to produce in the context of a normal world where we're just having normal discussions about the Earth being round versus the Earth being flat, and especially in science, where we all accept that the Earth is round, not flat, and accept that there's a mathematical and scientific and physics difference in that. These comments from scientists should be impossible, right? Yet, here we are. So, of course, the explanation for that is in my book, Planet Wars. They're kind of not real people or something. Yeah, so that purpose is the extinction, the total transformation of life. Well, it would be the end of life on our planet. It seems to be what it's a paradox. So look at the result of the paradox. Oh, the result of the paradox is that it would lead to the end of all life on Earth. Okay, well, is that something that humans would want to do? Okay, well, these paradoxical comments, which seems to be coming from humans, aren't comments that humans would make. And the result of this is something that humans wouldn't want normally. So draw the conclusion about what are the entities that are making these kind of statements, right? And from there, you need to draw on wisdom, which is simply not common to the mainstream. Read my book, Planet Wars, if you haven't yet. Oh, here's a good one. I just threw this in. Yeah, John Kerry recently said, we've got to cut down on farming due to climate change or people are going to starve. Yeah, oh yeah, because farming is going to make people starve, but stopping farming will not make people starve. Right? Insane. We're dealing with insanity. So anyway, back to the ontological, yes or no. The difference between flat Earth pedagogy and understanding the basic feature of the climate versus a spherical Earth approach is this simple distinction. Flat Earth, the climate is not created or sustained by the sun with minus 18 degrees Celsius heating from the sun. That's flat Earth. Flat Earth, the result of working out flat Earth theory as as pedagogical climate, you get the result that the climate is not created or sustained by the sun because the sun only has minus 18 C heating. Therefore, a greenhouse effect is postulated to create the climate. Now, sphere Earth, the climate is created and sustained by the sun because the sun actually has its empirically confirmed value and theoretically confirmed, theoretically calculable and empirically confirmed, plus 121 degrees Celsius heating. Okay, so is that a difference? Climate not created by the sun, climate created by the sun. Is that a scientific difference? These people will say that no, it's no scientific difference, right? Those paradoxical people, they're saying no, there's no scientific difference there. Therefore, there's no need. Yeah, so with sphere Earth, there is no need to postulate a greenhouse effect to create the climate because, of course, you can also use the adiabatic physics, the adiabatic effect, which is what explains the temperature lapse rate. They use the greenhouse effect to explain the temperature lapse rate. But, their greenhouse effect is coming from flat Earth theory in the first place. The adiabatic physics is coming from well-known, well-established thermodynamic physics and, nicely fits into spherical Earth model. Okay, even simpler, is there a difference between minus 18 degrees Celsius and plus 121 degrees Celsius for solar input? Is that a difference? Is there a difference between those two numbers? Is there a difference between those two temperatures? They'll actually deny that there is a difference between those two temperatures, that it's relevant. So is there a difference? Of course there's a difference. So The climate science academics and supporters say no, and they will insult you for asking the question, and they will tell you that your sphere is a flat line and therefore wrong, and that their flat line is actually a sphere and therefore right and correct, and accuse you of harassment from mathematically explaining the difference. See, they're politely doing pseudoscience, right? They're very polite about it, but they have a peer review system, and they're very polite people, and they never get upset. But then you spend 15 years getting these sort of ridiculous paradoxical comments where they're accusing you of being a flat earther, where you've just literally drawn a circle for the sphere, and a circle, representing a sphere for the Earth, and they'll say you're the flat earther. I mean, yeah, of course, at some point you get a bit irate and you get a bit righteous, you get some righteous indignation, and you're like, you fucking dickheads, and they're like, you just got emotional. You just harassed us. You don't get to talk to us anymore. Meanwhile, they're harassing the shit out of you and playing, and saying these freaking ridiculous gaslighting comments, which is harassment, right? They get to freaking insult you as much as possible and fire you and stop you from being able to work and have a career in science anymore. Oh, but that's not harassment. That's very polite because they're peer reviewing their position. You see what we're facing? Guys, this is real world. This is a real world. It's a real world problem, right? This isn't going to go away. These people want to freaking do what I concluded they want to do to the planet. So please, guys, we got to survive. We got to survive. Please support this work if you can. Bitcoin, their PayPal, nice easy way to do it. I have this thing on Give, Send, Go as well, ontological mathematics. So we're going to, guys, you see what's happened to science? Do you see what's freaking happened to science? Do you want me to save it? Do you want me to help try to freaking create a new curriculum to return reason to science? I mean, you should see what's happening at the universities now. Even in STEM, even in astrophysics, they're trying to figure out how can we freaking incorporate transgenderism into physics and astronomy. A lot of you might not know this story, but we had that I worked on a space telescope called UVIT, right? That was my career. Worked with the Indian Space Agency and Canadian Space Agency. I did, had major contributions to its development in Canada. And then in orbit, I wrote the data reduction pipeline, which didn't exist when it went to orbit. The Indian contractors didn't have the pipeline finished yet. So I wrote one from scratch during a visit, and then continued improving a data reduction pipeline. And so I was responsible for getting the first light images of this telescope from space to confirm that it was working. I was responsible for getting those images, and then subsequently developed that software into a data reduction pipeline. Anyway, lots of stuff. I have a libraries on GitHub for my work, solved really important problems in astrophysics. Why did I get into that? Yes, right, about the story. Right. So anyway, that's my history with working with space telescopes doing real science. So we were going to develop a new one, the next generation, because of course that's what you do. You go from Hubble to the James Webb Space Telescope. So we're going to go from UVIT to the next generation ultraviolet detecting telescope. Ultraviolet is important, and it's not what the other telescopes are looking at. Ultraviolet is important and unique to what we had been doing, because you can tell what's unique about it is you can see star formation rates. It's just a much sort of higher temperature regime sort of light physics to look at. A lot of very interesting physics happening in the ultraviolet, right? So we're going to have the next generation telescope, bigger, better, all that sort of stuff that we love to do. Bigger and better next generation, right? More data, better data. We had the best scientists in Canada, top rated scientists in Canada, and all around the world wrote up the proposal. We knew that the CSA, Canadian Space Agency, and the Indian Space Research Organization would be offering funds and would be supporting the development of this. This would have produced at the University of Calgary 20 years easily worth of research and development. It would have generated easily a dozen, probably, master's degree students, PhD students. It would have been and then summer work for students to help with data analysis development. It would have been a great project. Money was ready to go. So now that we have these diversity, equity, inclusion officers, which basically just means everything you have to do has to be homosexual and gay and tranny. They're in charge of everything now. They now run bureaucracy of everything. They get to determine everything that happens now at a university. We had this wonderful proposal. Money was ready to go. The money was going to come in. They shut down and refused this project from being able to operate out of the University of Calgary, which is where we were all based, because we did not specify in our proposal for this new space telescope, a telescope that's going to be in space looking at galaxies, we did not specify how it's going to help the LGBT community and help solve climate change. So you tell me how a freaking telescope that's in space looking at galaxies and star formation is going to help trannies get their operations and have tranny sex or whatever the hell that it is that they do, and freaking solve climate change. You tell me. I mean, it's just so absurd, right? But that's what's happening now at universities. So yeah, going back to this, we need to create a new system. A new system. Whatever's happening, it's like, we'll salvage it. No, there's some sort of parasitical force in work. We need to create a new system. You know, what's that? Who's that quote by? Is it, well, it's kind of like from Einstein. But it's also from some science fiction guy. I can never think of names when I need to. Anyway, just, you know, when you need to solve a problem, instead of just fixing the old one, just create a new paradigm, which makes the old one obsolete, right? So that's kind of what we need to do and solve somehow. And that's what I would really love to work on. I might not be able to, given that I need to do other things to survive in the interim. You know, that's not my kind of mind. Not good with money, like, you know, like some other people are. Anyway, wow, guys, right? Oh yeah, here. If you haven't yet, I know most of you have already, but you can read my book, Planet Wars, for what I conclude and discover about what the force is behind these people making paradoxical comments in science that make no sense whatsoever. These are supposed to be scientists, yet they're quite openly defending flat Earth theory when it comes to climate science. And like I said, you analyze why would they defend that there? You look at the conclusion, and it's like, oh wow, that's a pretty bad paradoxical conclusion coming from paradoxical statements that seems to be internally consistent then for some other goal. And well, the goal is just you look at what they're asking for. You just look at what they're asking to be able to do, and that's what their goal is, right? So of course, I mean, if you want to read them all, yeah, do read them all. You can read the arc of development. Yeah, you guys have seen most of this before anyway. So anyway, guys, that was a real fun one. Went an hour. Oh my gosh. Didn't mean to, but I guess it was a lot of fun, wasn't it? So nice to see you. Nice to talk to you. And hopefully we survive. That's all I can say. Hopefully we survive. Hopefully there's some avenue or vector or thread through this scheme that we are obviously facing. That basically we can say photo. It sounds absurd, but it's just what is. Maintain photosynthetic life on this planet in the face of these paradoxical people who want to blot out the sun and remove carbon dioxide because they've said that those are the most evil things of all. Gonna try to keep smiling. All right. Okay. See you guys. Take care. Bye-bye.